we're going to start things off by trying to graph something together. Right? So your calculator can actually draw graphs onto those Cartesian points with the x's and y's. The first thing to do is to put the equation you want to graph into your calculator. This is the equation that we're going to try to graph. Right? So the first step is to enter that into your calculator. You hit the y equals button. It's in the top left corner of your calculator. That's going to bring you to a list of things. And it looks like this right here. It should be completely blank right now because we'd all reset our calculators. In y1, you're going to enter this equation. When you enter that equation, there's a few things that are important. The first thing being that this is a negative sign, not a minus sign. The negative sign is beside the decimal. So you need to do negative and then 1.25, and then you need to learn where the X button is in your calculator. There's a couple different X buttons. The one you want to use is right beside the word alpha. So there should be a button that says X, T, theta, and N. That's the button you want to click for X. So you go negative 1.25, X, and then plus 15. Pardon?
Yeah, just press alpha again. And get rid of it.
You don't have to click alpha, you just have to click the X.
Yeah. I can get one.
Yep. Yep. So you should just hit the X button and it'll come up. You don't have to click alpha or second or anything like that. Does that work for you?
Yeah.
Awesome. Alright, the next thing is to actually graph this equation that you just told your calculator about. But before you graph it, what I want you to do is know that you need to set a window, because your calculator doesn't know what it wants your Cartesian plane to look like. You know how we draw things like this? It doesn't know what you want. It could go from 0 to like 1 million. Ooh, that's a lot. It could also do from like 0 to 2. Like, it doesn't know what you want to graph. So you have to tell it what you want to graph, how big you want that thing to be. To do that, click the window button beside the y equals button. When you click the window button, it should bring you to a list that looks like this. Each one of those things means something different. It explains it right here on your notes what each thing means. The ones that we really pay attention to are X min, X max, Y min, Y max. The others, I just leave them the way they are. I just leave them at that standard setting. It's 1, 1, and 1. Alright, what X min and X max mean? That's saying this is the lowest X value that you'll ever have on your graph, and the highest X value you'll ever have on your graph. So if you're thinking about a graph, that means they're talking about how far left and right you're going to go. X min is over here. X max is over here. When we're graphing something that's in no context, like we have no context to this equation, we're just told to graph it, we use something called the standard window, or the standard setting. The standard window is -10 and +10. So that way when you graph your thing, it'll start you off at -10 and +10 as your two bars. Your Y min and your Y max we change a lot too. So Y min is the lowest that you're ever going to see, and Y max is the highest that you're ever going to see. Again, when you're graphing something for the first time and there's no context to the equation, you just leave it in the standard setting, which is -10 and +10. So the standard setting is to see -10 down, +10 up. We call that our standard window. Alright, now that we've picked this window, which it should have already been picked for you, I want you to hit the graph button. The one in the very top right-hand corner, that's going to actually graph what the equation was. When you graph it, it should look like this. Did everybody get that graph?
Yeah.
Awesome. What that graph is your Cartesian plane. It has a y minimum of negative 10, a y maximum of positive 10. It has an x minimum of negative 10, and an x maximum of positive 10. And each little tick represents 1. Yeah. Maybe just push sideways, or you can go see Miss Tucker or Miss Shaw and ask if they can do one, if they have one. On that Cartesian plane, they should have graphed a line somewhere on it. You know that. Our line showed up right here. That blue line is the equation negative 1.25x plus 15. That blue line is that equation. And you can do that for anything. You'll be able to bring up the line and graph it and look at it, and then you can analyze the graph, do whatever you want with it. Now, this is not a very good picture of our graph. I wouldn't call this an appropriate window. The reason why it's not an appropriate window is I can't see my y-axis. I can't see, my y-intercept, and I can't see my x-intercept. I don't know where either of those things are. It's probably somewhere over here, right? It's probably somewhere up here if I was to guess. I also have a lot of wasted space. So if I look at my graph, I have all of this space over here that's kind of just wasted. There's nothing in it. This is how I'm going to now select a new window and a more appropriate window for this equation. So I want you all to go back to click your window button. So you're back on your window button. It should look like this. There you go. That should be what you do. What we're going to do is set a window that makes more sense for us so that we can see the X-intercept and the Y-intercept. Looking back at your original graph, the first thing it says is X minimum. Did I need to be able to see all the way to negative 10, or was that maybe too far? That's too far, right? Like, look at all this extra space. So maybe a better X minimum was like negative 3. And then what it's going to do is it's going to cut the graph off a little bit so that you don't have so much wasted space over here. So change your X minimum to be negative 3. Make sure you're using negative 3 and not minus 3. The negative button is beside the decimal. The next thing is X max. So using your little arrows on your calculator, you can move down to your X max. If I look at my current X max, it was at 10. But if I was to look at this graph, my X-intercept is going to be past 10. So I need to go higher than 10. I'm just going to guesstimate. I'm going to say, I think if we made X max of 15, I would then be able to see my X-intercept. So I changed my X max to 15. It then should say XSCL. I just always leave that as 1. The next thing is my Y minimum. My Y minimum was negative 10 all the way down here. That was probably a little too low, right? There was a lot of wasted stuff down there. I wasn't really seeing anything down here. So I'm going to change my Y minimum to be, let's say, negative 5. What that's going to do is it's going to bring the graph up a little bit, so I don't have so much wasted space there. So my Y minimum is negative 5. And then finally my Y maximum. If I look at my graph, I can see pretty high, but I know my Y-intercept is going to be higher. Just looking at my graph, this line must come somewhere up here. I'm going to make my Y maximum 20. So I'm going to go quite a bit higher because I think that Y-intercept is quite a bit up there. And then I'm going to hit graph again. So when I hit graph again, oh, I didn't change mine. Your new graph should look like this. something like that. You should have your axes like that. You'll notice that you're much more zoomed in up here. You no longer see all that wasted space. And you can now see your Y-intercept right there and your X-intercept right there. And that's your goal when you're setting a window. You want to be able to see your Y-intercept and your X-intercept. That work for everybody? First time through? All right, that's good. Knowing how to set a window is like the biggest battle when it comes to graphing. Right? Like people have a really hard time when it comes to window settings. You can always go back to your standard window by just going X min, X max, going -10, +10, -10, +10. Your calculator also does know a shortcut on how to get to the standard window. To get to the standard window, you just follow these settings right here. So you click the zoom button, which is the side window. And you click number 6, which is the standard. See, it says Z standard, I mean zoom standard. And that'll automatically change your graph back to +10, -10. All right. A couple questions that we're just going to fill in together. Why didn't the standard window work for that graph? Why did we have to change it? Okay. You couldn't see the X or Y. Anything you graph, you should be trying to see those two things. I want you to try to graph this equation right here. So you're going to put that now in your y equals. You can delete the other one away. And I want you to try to set a window that'll work for this question. So try to graph that. Try to set a window that actually works so you can see your intercepts. Give it a shot. Notice that this one says y equals. You don't have to put this part into your calculator. Your calculator already has the y equals. This part you have to actually put into your calculator. Yeah. You have questions? Yeah. And I'll come around and I'll try to help you if you get stuck. That if you graph this thing without changing your window and you use your standard window, my guess is that you have to graph that little thing. Something like that. It should have been the initial graph that you got. If I look at that, this isn't what we would call an appropriate window because I can't see my X and my Y intercepts. I can see my X intercept, it's right here. However, my red line, my graph, does not cross my Y-axis in my current window setting. My guess on where it's going to cross is somewhere down here. Okay? Just by looking at the axis and looking at the line, it kind of makes sense it's going to cross down there. And it doesn't seem like it's really going to be that far away. Like right now I'm at -10. I probably have to be able to see a little bit lower. If you want to fix your window so that you see lower, in your window settings, which thing are you changing? You're changing your Y minimum. Because that's the lower part of your graph. I think a good Y minimum, if I was to guess, would be -20. Now, some people did a little bit more than that, -25. Some people did a little bit less than that, maybe -15, -17. But either way, what it should have done is it should have given you a little bit different of a graph. It's the same line, it's just a different view of it. Now, some people even went a step further and they realized that they had a lot of wasted space. They'd wasted all this space over here, and they even brought it in a little bit, and that's awesome if you did that. So if you even changed your X minimums and stuff like that, that's perfect. Your goal should always be to let your graph fill up as much of your screen as possible. Less dead space is better. At the end of the day, though, your goal was to see your X-intercept and your Y-intercept, and you should have hopefully done that. All right. Using your calculator to actually find things. So there's a whole bunch of step-by-step things in here. We're not going to do them together right now. We're going to go to an example and then come back and look at each step-by-step. This is like a perfect thing for you to reference if you're like, I don't remember how to find this using my calculator. So this one tells you how to find a Y value, so an output, if they tell you an input value, an X value. This one tells you how to do the opposite using your calculator. How to find an X value, an input, if they gave you a Y value, an output. The next thing is how to find X-intercepts. Your calculator can calculate where X-intercepts are, the actual numbers. So you know how you guys were doing it by hand before? Your calculator can do it with just a couple clicks of a button. It's kind of nice. Number 7 is how to find Y-intercepts. We do have to fill in a blank here. The trick to knowing how to find Y-intercepts is remembering that all Y-intercepts have an X value of what?
0.
Perfect. So you want to fill in that blank so that you remember that that's the trick. And I think the last thing that we have step-by-step instructions is how to find the vertex of something. We haven't talked about vertexes or vertices. We will today. We'll hopefully get to an example where you have something called a vertex. And I'll teach you guys how to find it. All right. Here's our example. We're going to try this example together. And we're going to try to find a whole bunch of things using this example. The first step says sketch the graph. So I want you to try to graph this thing in your calculator with the standard window setting. So try to graph that using the standard window setting. We want to write out an appropriate window. How I write out appropriate windows is I literally just write out X min, X max, and then Y min, and Y max. There is other ways and formats to write it, but I don't stress too much on that because that kind of confuses people, especially when you're just learning this early on. So I just am very blunt and write it out like that. I use the standard window setting to start. In my standard window setting, can I see my X-intercept? Definitely I can. Can I see my Y-intercept? I definitely can. I got a little bit of wasted space up here, so maybe I could change my X minimum. But at the end of the day, that's a pretty good graphic. That fills most of my needs. So I'm going to just stay with the standard window setting. -10, +10, -10, positive. That's an appropriate window in my mind. On the next slide, we have a bunch of questions about this graph. I'm going to try to... see if I can. All right. So there's my beautiful graph. Here's a bunch of questions for it. Now you could do these questions by hand, like you have that ability. This is what we've practiced up until this point. Or you can answer these questions using your calculator. Today we're going to try using our calculator. So this first question says, determine the value of y when x equals 10. So they've given you an x value. If they've given you an x value, you are going to use these steps right here. Right? How to find a y when given an x. You want to be on your graph. When you're on your graph, it should still look like this thing right here. You want to click the trace button. The trace button is beside the graph button. So you click trace. When you click trace, On the bottom of your screen should have popped up something. It says X equals and Y equals on the bottom of your screen when you hit trace. Did that happen? Awesome. You can type in the number. So then just go 10. And on the bottom of your screen, you'll see it says X equals 10 right now on your calculator. Hit enter. And then it'll say X equals 10, Y equals. That's what Y equals when X equals 10. In this case, the answer is 14. A couple important things to talk about right now. The first thing, there's different ways to do things. So you might have another teacher who has a different way of finding what Y equals when you're given an X. Right? So if you see another teacher doing something different, then feel free to learn their way. I try to show you whatever I think is the easiest way. Okay? So that's what I go with. The other important thing, recognizing that your calculator has a lot of abilities, and the only way to really get good and remember all of them is to practice it. This is like the easiest thing that you will do, is if given an X, find a Y, because it's like 2 buttons. Trace, put in the numbers, enter. Question D. Determine the value of X when Y equals 8.75. Now you're looking for an input value given an output value. Unfortunately, your calculator does not know how to do that. It doesn't have a simple way of saying, oh, you have a Y value, here's what the X equals. So instead you have to do a little bit of a trick. If you look back, this is number 5 on your step-by-step instructions. That trick that we're going to do is we are going to draw another line on our calculator. And that other line is going to be at Y equals 8.75. So you're going to hit Y equals. In your Y equals, you're going to go down to Y2 equals. You're going to leave Y1 as the original graph. You're down to Y2 equals, and you go 8.75. Nothing else. And then you hit graph. And what you should end up with is 2 lines on your graph now. You're going to have the original line that we had, and then you're going to have a line that's right here. Horizontal line. That line is where Y equals 8.75. All the time. It's all the spots that Y could be 8.75. The reason we do this is your calculator does have the ability to figure out where 2 lines cross each other. Your calculator has the ability to figure out that spot right there. If you can figure out that spot right there, then you can figure out what X value gives you a Y value 8.75. To do that, you're going to go second trace. Second trace. That's going to bring you to a list full of things. The top of the list is value, then it should say 0, then minimum, then maximum, and then intersect. That's what you want to find. You want to find where these 2 graphs intersect each other. So you're going to click number 5. It's going to bring you back to your graph, and on the bottom it should say first curve. Okay, first curve? Awesome. You should also be able to use your left and right arrows to move a little cursor on your graph. So if you use your left and right arrows, you should be able to move your cursor around. Are people doing that? I want you to move that cursor using only your left and right arrows somewhere up where these things cross each other. Just near it. You don't have to be exactly on it. You just have to be like beside it. So move your cursor up into where that is. And then you're going to hit enter. When you hit enter, on the bottom, it now says second curve, question mark, correct? Hit enter one more time. And then on the bottom, it should say guess. For some reason, your calculator has a guess feature. I have no idea why you'd ever want to guess. You're like, I don't know why you'd ever want to do that. Okay?
When it says put an estimate.
Yeah, like, I don't know. It's so weird. I've never understood that.
Mine doesn't say that.
You just went straight to the answer?
No, mine just says second curve, and then when I press enter, it still does 2 steps.
Same thing. How many people are stuck on second curve question mark? Just you two? Okay, click your down arrow, and then hit enter. Okay, so what happened, and that's going to happen to you guys in this room as well, is if you had accidentally bumped your up or down arrow at some point, it'll switch which line you're on. And your calculator will get confused about which lines you're trying to find the intersection with. That's why it's very important to only use your left and your right arrows when moving your cursor, because that'll help you avoid that problem. Okay, so only use your left and your right arrows to move things around, and you'll be set. You hit enter, it went to guess now? Awesome. You don't ever want to guess. So hit enter one more time, and it'll tell you the actual answer. It should say x equals something, y equals 8.75. What was that x value? 7.375. Awesome. That's how you can find your input if they've told you an output. Much easier than using all that algebra and those tricks. The next thing that your calculator can do is it can find intercepts. We're going to start by finding our Y-intercept. The reason we're going to start by finding our Y-intercept is it is actually the easier one to find. The reason it's the easier one to find is when they ask you for a Y-intercept, what they're actually doing is saying, what is Y when X equals 0? That means when they say, what's your Y-intercept, they've actually given you an input value. If they've given you an input value, it's exactly like doing question C. And question C was simple. You just hit trace, put in 0, and hit enter. And it'll tell you that when X equals 0, Y equals -6. So Y-intercepts are either the easiest or the hardest because people forget this trick. Y-intercepts X equals 0. All right, the X-intercept. Not as easy, a little bit tricky. What I first want to do is I want to get rid of this 8.75 line because I don't want it to screw anybody up. So if we go back into our Y equals, go to your Y2, and if you just hit the clear button when you're on top of Y2, it'll get rid of that 8.75 line, and then if you graph it again, it'll be gone. And you'll be back to your original line. I like to do that because your calculator sometimes gets confused and it'll try to find X-intercepts of other graphs that you don't actually want. So I prefer to only have what I want to be working with on my screen. All right, to find your X-intercepts, you go second trace. Second trace. And it brings you back to that list of things. Value, 0, minimum, maximum, intersect, dy over dx, weird integral sign, f bracket x, dx, that big list of things, right? What I don't want you to click is intersect, because you're not looking for an intersect. You're looking for an intercept, right? Two different things. Most people end up clicking that button and then they get lost. Instead, I want you to click the second option. Because X-intercepts have another name in math. It's called a 0. And that's the wording your calculator uses. So when you go second trace, you want to click the 0 option. Second choice on your list. When you click that option, it's going to bring you back to your graph. And you should have a cursor somewhere on your line. And on the bottom, it should say left bound. Correct? What your calculator wants you to do is it wants you to tell it where to look. We are trying to find our X-intercept point, which is right here. You need to tell it a spot on your graph that's on the left side of that X-intercept. So what you need to do is move your little cursor using your left and right arrows somewhere over here. You don't have to be right on your X-intercept. You just have to be a bit past it to the left of it. Some people have a hard time envisioning that as being to the left. They sometimes look at it and go, it's below it. It is below it, but if you drew a dotted line straight up and down, you'll notice that this is the area that's to the left of my X-intercept. So move your cursor anywhere down into that region that I've circled. If it's straight on it, it might not work. So you go a little bit past it. Anywhere in here, like you can't, like, the only way you can screw up is if there's more than one X-intercept somehow, and you've gone past a whole bunch of them. So, like, you could come all the way down here with your cursor and you're fine. You could also be close to it and you're fine. Just as long as you're for sure past it and to the left, you're good. You hit enter, and then it should say right bound, question mark. Now it wants you to pick a spot that's to the right of your X-intercept. So now you need to move your cursor somewhere up here, into this area. When you move your cursor up there, hit enter one more time, and it's going to say guess. But before we guess, I want you to look at something in your calculator. So, you should have clicked left bound, enter, right bound, enter, correct? Now, depending on your calculator, oh, that did not work out how I wanted it to. Look at that. That's okay. Your calculator actually will show you something. And most people don't know about it. But if you can understand what it's showing you, it's very useful. On the top of your screen somewhere, you're going to have little arrows. The older calculators, I think your arrow looks something like this, and it's shaded in. On the newer calculators, I think they draw that arrow, and then they even do a dotted line with that arrow. Okay? You should have two arrows, one there and one here, somewhere close to that area. Your graph where those arrows are. Those arrows are actually telling you something. They're telling you that the calculator is going to look for your X-intercept in between these two arrows. It's going to look all in here for an X-intercept. And if there's no X-intercept in between your two arrows, then it's not going to work. Or if your two arrows are pointing opposite of each other. So if my arrows were screwed up and I had my arrows pointing like that, it's not going to work because there's no region for it to look in. So you want to make sure that your arrows are actually making sense and your calculator's actually looking in the right area and your X-intercept exists in between those two arrows. Yeah. No, sometimes it's best just to do it by hand. Yeah, and that's fine. And to each their own. Like, some people will go a long time without actually using the calculator because they just hate it, right? It becomes kind of inevitable come grade 12. So it's good practice to get to that point. But with some of these calculations, you can do it by hand way faster than a calculator, especially if you're strong with, like, your mental. Okay. It says guess on your calculator. You don't want to guess, so you hit enter one more time to get the exact location of your X-intercept, which should have been at 3, 0. That works for everybody? Awesome. We're doing good. This is the best it's ever gone. All right. The last question. We're going to try to write out the domain and range. This is what we learned for 4.4. Domain and range. Domain and range is a way of asking you for possible X values and for possible Y values. Let's start with domain. Domain is asking you what are the possible X values for this graph. If you looked at this graph, that means it's asking you what's the furthest left it ever goes and what's the furthest right it ever goes. This graph, how far to the left will it go? Forever. It's going to go forever to the left. How far to the right is this thing going to go? Forever. It's going to go forever to the right. That means X could be any number. If you just kept zooming out, you would see more and more and more. We say X is an element of the real. X, that's your domain. X could be any real number. It could go forever to the left, forever to the right, and you're good.
question above, how, like, about the 3, why couldn't we have just looked at it and counted how many spaces were on it?
You could. So for this question, you could have. But if it was slightly over, maybe the answer is actually 3.1. Right? So sometimes counting will actually miss the fact that it's not a perfect round of 3. It's like 3.05. Yeah. All right, range. Range is asking you, what are the possible y values for this graph? Or how low or how high could you go with this graph? If I kept zooming out, how low would this graph go? How low would it go? It would go forever, yeah? It would go all the way down. And how high would this graph go? Forever. That means we have no lowest point, no highest point. We could be any value of y, so we say y is an element of the reals. It could be any real number. And somewhere on the graph, it would work. All right, that's like a majority rundown of all the things we do with our calculator. It's quite a bit, right? And it's a lot of buttons and knowing where things are. Each one individually seems simple, especially as we're doing it together, but then trying to remember all of that could be a bit of a headache. There's another question here. I want you to try your best to answer everything except for C. Do not worry about doing the vertex right now. We'll do that together. And if you get stuck on the X-Intercepts, that's A-okay. But I want you to try to graph it, pick a good window, and set it all up. So try your... The first thing we're going to try to do... We're going to try to find a y value with x equals 10. If they give you an x value, that's the easiest one. So you're going to hit graph on your calculator. You should be on your graph right now. Then you click trace. When you click trace, on the bottom of your calculator it says x equals y equals. Just put 10. And on the very bottom of your screen, you'll see it even lets you edit it. It says x equals 10. Hit enter. The correct answer when x equals 10 is y equals 20. When they give you an x value, that's the easiest one. Just go trace, figure it out. E, probably the hardest one in my opinion. The reason it's the hardest one is people forget that your calculator can't actually do this. So instead what you have to do is draw a second line. You need to paste into your y2 that it's equal to negative 10. You don't put any x's in there or anything, you just go y2 equals negative 10. That'll draw a line exactly at y equals negative 10. So when you go back to graph, you should have 2 lines. Mine's blue and mine's red. Those new calculators actually color them differently too, right? Like the really fancy ones. Yeah, the ones that say CE at the top of the calculator actually, yeah, do color. Color edition. They're the skinny ones that don't have batteries. Anyways, there's a problem here. If you look at this graph, you'll notice that it intersects in 2 spots. It intersects once over here and another time over there. That means you have 2 calculations you need to make. You need to find both those spots. To do that, you go second, trace. That'll bring you to a list of things. You want to use intersect. I believe it's your 5th option. Correct? Second, trace, intersect, 5th option. Thank you. That's if you're finding X-intercepts. This is finding where 2 lines cross each other. We're trying to find intersecting points. So this one, you want to find where they're intersecting. When you go second, trace, intersect, it should say first curve. I think mine, when I first did it the first time, it took my cursor all the way down here, kind of halfway in between the 2 fingers. You need to just pick whichever one you want to find first. It doesn't matter which one you find first. But just choose one, go to that one, and hit enter. So I move my cursor all the way to the left, up here, and I hit enter on it. Then it says second curve, and I hit enter. Then it says guess, and I hit enter. And it should tell you that when y equals negative 10, that x equals negative, what do you get it? 8.72. 8.72?
decimal.
Sorry if that's
0.87.
The 7 point something is natural. Anyway. Second trace intersect when y equaled -10, x equaled -0.87. Now you need to do it again, but you need to find the other spot where they're intersecting each other, the one on the right. So you have second trace intersect, you move your cursor all the way to the right this time, and you hit enter over here. It says second curve, you hit enter again. It says guess, you hit enter again. And it should say that x equals 6.87. That makes sense. They usually end in the same decimal. You'll learn why it ends in the same decimal. Alright, that's finding x values when given y values. We don't have to do that a lot, but it is a useful tool. Alright, F. State the x and y intercepts. We're going to start with y-intercepts. But before we do anything, we're going to delete this second line out. Remember, we don't want to have too many lines on our calculator when we're working with it. Sometimes that screws things up. So once I'm done using the second line, I delete the second line. I'm going to start with my y-intercept. The reason I'm going to start with my y-intercept is y-intercepts mean x equals 1. If they give you an x value, then you just have to hit trace, 0, enter. And it'll tell you that the y-intercept is at 16, negative 16. X-intercepts is a little bit harder. X-intercepts, you have to use your knowledge that it means the word 0. So when you're searching for your x-intercept, that's when you're searching for your zeros, right? It's another name for x-intercept. To do that, you go second trace, and you pick the second option, which is 0. And it's going to come up to your screen, and it's going to say left bound. Now, what it's asking you is to show it a spot on the graph that's to the left of your x-intercept. You should have 2 x-intercepts, which means you need to just choose one to find first and then do the question all over again to find the second one. You can't find both simultaneously. So let's look for the one on the left first, this one. To find that, you need to go left bound of it, somewhere up here. Then you need to hit enter, it's going to go right bound, you go somewhere just below it. You hit enter, it says guess. You check to make sure that your x-intercepts are between your little arrows. You hit enter one more time, and the x-intercept should be at -2? It should be really close now. My calculator's so dead I can't get to it. -2 exactly? You then have to do it all over again to find the next intersection point. So you go second, trace, intersect, and you're going to go, or sorry, 0, and you go left of it. So now you're down here. You hit enter, then it says right bound, you go somewhere up here. Hit enter again, it says guess, hit enter again, and it should be at 8, 0. Yeah, no, I wish. There is no quick way to switch it over. You can hold it, and sometimes it'll go a little faster to hold the button down, but really there's no good way to do it. All right, the last one that we're going to learn. I wouldn't be packing up yet because we haven't learned how to do a vertex yet. So, to find a vertex needs to find the highest or the lowest point on a graph. That means you have to have something that has some sort of curve to it. Right? A straight line has no high or low point. This thing does have a high or low point. It has a low point right there. We call that the vertex. we're not going to stop this class until we figure this out. So if you're packing up, that means you're just going to have to wait through your lunchtime. The vertex has another name to it. It's either minimum or maximum, depending if it's a low or a high. This thing is the lowest point, which means it's a minimum point. Your calculator has the minimum function on it. So to find a minimum point, you go second, trace, and minimum. That'll take you back to your graph. It'll say left bound, right bound. You need to go left of your minimum point, somewhere up here. Hit enter. Go right of your minimum point, somewhere over there. Hit enter. Hit enter one more time, and it'll tell you exactly where that minimum point is. This one's at.
Walker, Michelle Parker, Hunter Disquire.
Awesome. So we would round that to 3 and negative 25. So you make sure you round it if it's at 2.999. Awesome. We'll see you all tomorrow. I need all my calculators back, please.